So this is where it's going to get a little crazy because we're going to finish a cycle here. That means halfway is here, which means I'm going to go down to the minimum halfway between those 2 points and up to the maximum halfway between those points. So one cycle, we start at 0, it goes down here, back to 0, up here, back to 0. Now, I might do 1 or 2 more of those, but I don't want to fill in the whole graph because that will be a little crazy, right? Let's just do, I'm going to do 1 forward and 1 backwards. So again, from pi to 2 pi, halfway is an x-intercept, and then halfway between pi and 3 pi halves, we're down at -3, and halfway between 3 pi halves and 2 pi, we're back to +3. So it would look like that. Okay, now if you're like, if this is too sloppy, could you just go on Desmos and put this in? Yeah, and it would be great, okay? We actually don't have too much time for that, so let's just keep on rolling here. Before I do you have any questions on this? Is this making sense as far as vertical stretch, horizontal stretch? Okay, awesome. The next thing we're going to talk about, which is actually not too hard, okay, is if we're talking about frequency, this is actually just the reciprocal of period. If you remember, period is 2 pi over b. Well, frequency is b over 2 pi. What frequency tells you, frequency is the number of completed cycles the wave completes in a unit interval. What we've been kind of saying is when we do 2 pi over b, it's like how long it takes to complete a cycle. This is just the opposite. So if I'm looking at this graph down here at example 3, what am I multiplying by on the inside? Usually it's just a plain old x. What do we have here? So b is 2/3. Now if we were doing period, period is 2 pi over 2/3. Which if we keep change flip, multiply by the reciprocal, that's going to be 3 over 2. And the 2's cancel, so that's just 3 pi. That's what we're used to seeing. And we would say, okay, that means it takes it 3 pi to complete one cycle. Okay? But now when we're talking about frequency, we're actually going the opposite direction. So I'm going to go the opposite, where I do 2/3, and then we're going to divide that by 2 pi. And for simplicity's sake, I'm going to think of that as 2 pi over 1. I'm going to keep change flip here and do 2/3 and times it by 1 over 2 pi. And so the 2's cancel, leaving me with 1 over 3 pi. Now, this is going to be the number of completed cycles the wave completes in a unit interval. That means at one interval, we've completed 1 out of 3 pi. Just the opposite way of thinking, okay? So remember, if it's asking for frequency, just do the opposite, b over 2 pi. Okay? Let's keep on going. And this is kind of just showing an example here. If we were to graph this out, you could see that the period was, this is 1 pi, this is 2 pi, and this is 3 pi. So you could see it took 3 pi to complete one cycle, or if I look at like one interval, it's only 1/3 of the way done. It's just the opposite thinking, okay? All right. Last one we're going to talk about is phase shift. And phase shift is when you make it go left or right. And then I think after this we just have, okay, cool. I'm just keeping an eye on the clock to make sure we finish on time. Okay, so let's try to draw this one out. Construct a sinusoid with period pi over 5 and amplitude 6 that goes through 2, 0. Whew. Okay, so let's talk about this. So sine is going to look like this. We could do y equals a times the sine of b, and then we're going to do x minus h plus k. We've kind of used different letters, but that's how we rat out our parent function. Okay, what was given here, guys? What's something obvious that jumps out at you? Amplitude is 6. Okay, that's easy. We can figure that out. Okay, so there's 6. We've seen period equals pi fifths before, and our formula is just period is 2 pi over b. Now, if I know that the period is pi fifths, what I need to do is figure out what is b going to be. Well, don't even try to solve this like by multiplying it out. Just think, if I go from 1 pi to 2 pi, then I go from 5 to what? 10, you're just doubling it, okay? So that tells us b is going to be 10. Okay? Now what we need to figure out is, did this get shifted up or down, or did it get shifted left or right? The only thing we know is it goes through this point 2, 0. So why don't we start off by graphing y equals 6 sine of 10x, or 10 theta, okay? And let's see what we would need to do to make that go through the point 2, 0. Okay? So let's practice graphing this. So I'm going to draw my x and my y here. Okay, so now let's graph a couple of our key points. First off, this is going to go all the way up to 1, 2, 3, 4, 5, 6. And then it's going to go all the way down to 1, 2, 3, 4, 5, 6 to negative 6. How long does this take it to go through a cycle? Pi over 5, right? So I'm going to come over here and actually write out, here's pi over 5. That means the halfway spot here is actually going to be pi over 10. Alright, so, where is, I'm going to change colors here. If I were to graph this, it's going to be sine. It's going to go like this. It's going to go up to 6, and it's going to go down to negative 6. So it's going to go like that. Okay. Are you okay with what I've done so far? Yeah? Okay. The last thing we want to talk about is, currently, this is the only key point that I really like here, is this goes through the point 0, 0. If we want to make it shift to the right 2 points, what do you remember about shifting it left or right? You have to do the opposite. So if I'm going to the right 2, what does that mean I'm going to need to put in there? Minus 2. Now, the other thing you have to be careful of is, notice how I wrote this out where it has 2 parentheses here, okay? So when I write this, it's going to look like this. Y equals 6 times the 6 times sine. Sorry, I almost forgot that. And then I'm going to do 10, but then I've got to do the quantity of x minus 2 like this. If we were to multiply this out, it would look like this. 6 sine of 10x minus 20. So this was kind of a commonly missed thing on the parent functions, is people would look at this and think, oh, it's going to the right by 20, but no, you have to factor out the 10, and that's how you see it goes to the right by 2. Okay, this is actually going to show up on your homework. Let me show you what it would look like on your homework. We're not going to do the whole thing. But if you were doing this example, it's actually on your homework for number 20. Someone might look at this and say, oh, it's going to the right by how much? Pi halves. But that's incorrect, because what would you need to factor out from both of these? Okay, so here's what I want you to think about real quick with your neighbor. If I were to factor out a 1/4 here, then theta's by itself, great. what number is still left on that inside? If you factor out 1/4 from 1/2, what's still there? Think about it for a second. I'm not going to tell you the answer for about 20 seconds, but I want you to think about it. If you factor out 1/4 from 1/2, what's left over? What do you guys think? Does anyone think they know what would go there? Nobody? Hiram's putting up a 2. A 2 what? Got to put a pi with it. In my mind, guys, it's easier to think about this backwards. All I know is that whatever this number is, when I times it by 1/4, what does it need to turn into here? It needs to turn into pi over 2. So if I times 2 pi by 1/4, what does it turn into? Is that pi halves? So good job, Hiram. He was able to figure that out. Okay, so what are your transformations here? I'm not going to graph the whole thing, but I want you to take 20 seconds, talk to your neighbor. There are 4 transformations here. What are they? Go, talk about it. All right, shout it out. What is the new amplitude? What is the new period? If you say 1/4, it's wrong. It's 2 pi over 1/4, which is what? Keep, change, flip. 8 pi. This is going to go, it's a phase shift to the right by 2 pi. And then, what does that minus 1 do? It goes down 1. Okay, now one of the things you picked up an assignment and you picked up the key, right? Because why do you have a key? Check your work. All right, so do this for your homework. You will have a quiz on graphing next time. So if you have questions, then just come in early on Wednesday or early tomorrow and get some help. All right, thanks, guys.